Recording in progress.
Damn, that's loud. Sorry. If I turn that. Yeah. Wow. Of course, the first thing on the recording is like, damn, that's loud. Okay. Hey, everybody. Or both. Actually, can you leave the door open so that people can hear that I'm in here? And if they bothers them next door, then we'll open. Let the world hear my voice. Yeah. So hey, yeah, I get to the classroom and there's like a ton of people in there and they're learning about the new Vanport building or whatever. And I'm like, I'm supposed to teach in here at 5:30, but you are definitely still in the middle of something. So it turns out there's an event that was booked by some people from the School of Education, and they're in there doing an orientation for people who are studying to be middle and high school teachers. And there's no way I was going to make 70 of those people move just so like the 3 or 4 people that show up here can watch me watch me live in the other classroom. Besides, we're not really doing any pair programming or anything. So this classroom, we're right down the hall in classroom 75 for 7, whatever it is, 47. What was it? Yeah, 47. If anybody who wants to come down to see it live. So anyway, welcome to week 2 of Advanced Programming with Java here at Portland State University. Got a bunch of stuff that I want to cover tonight. Everything from what we're going to spend most of the evening diving more into that Project Zero, that student project, so that we can learn more about test-driven development, more about Java development. But we'll also talk more about some logistics of the course, like how to test your programs and how to document your programs, how to submit your programs. Those will all be things that will be relevant to you in the next week because Project 1 is due before class next week. But I wanted to start out with what I call Prime Minister's questions. This is an opportunity for any of you, any and all of you, to ask the questions that you have, things that have come up during the week that maybe you weren't able to get answered in Slack, or maybe something that you're just kind of wondering about. So how has your week been? What did you learn? What did you experience? What questions, ideas, feedback do you have that you'd like to bring to class? Feel free to raise your hand either in Zoom or here in the classroom. Okay, well, your question is testing. About testing, yeah.
Are we going to discuss plans of attack this class?
Yes, we will. Plans of attack is all part of the how to document your projects. We'll be talking about that later. Yep. Okay, great. So it's Alex, right? Yep. Alex is wondering about integration tests and unit tests and what's the difference and how do I do it? We're going to see a lot of that tonight. So I'm not surprised then that sort of based on the very cursory overview that I gave last time, and if you watch the JUnit lecture, we don't really make a clear distinction between unit tests and integration tests, so we'll see a lot more of that tonight. Question chat. Let's see here. It's been great. Setting up was the hardest part for me so far, but it's all working great now. Great. Awesome. Glad to hear that. I hope that the getting started repository was helpful. There's a lot of documentation in there. And so then hopefully the instructions were clear. And if they're not, please feel free to submit an issue on that repository. And actually, I'll bring up getting started. Submit an issue. Feel free to submit an issue on this repository or make a pull request. We had a couple people make pull requests over the last week, and that was great. I really appreciate that. That makes it easy for me. I can just sit there and say, oh, this is a change that I want. And so then we're going back and forth on a couple of things, but all really great. And then you two will be famous on the GitHub because if I merge your PR, then you two will show up here in this list of contributors. Anything else I can tell you? Anything else you'd like to know? So yes, in the first assignment, you don't need to use the javadoc date class. That comes with Project 2, I believe. Is that right? No, Project 3 actually is when it's required. But if you want to play with it now, if you want to read ahead and learn about it, or maybe you've already used it in something else, yeah, feel free to use it. It's so that you don't have to for the first two projects. Yep. Okay, then. We will call Prime Minister's questions complete. Awesome. Okay. I'd like to begin class with talking more about that Project Zero, the student project. So the idea is this is a project that we use as a teaching mechanism here in class during the classroom time. And really, it's an opportunity for me to demonstrate some things to you. Okay, a whole bunch of people walk by. I'm like, oh no, this isn't their classroom. I hope, but it looks like it wasn't. And give you an opportunity to see me working with some other code beside the student. So we'll look at the human class. We'll learn about inheritance and virtual methods, so how to override things and what it means to override things. And then probably most relevantly, how to read program arguments from the command line. So the student project is very much in the vein of your phone bill project, but it's not exactly the same. So we saw some of this yesterday, but I just want to review it. So when you create the student project, you get this student class, which extends human. Human is in my package, the edu pdx cs410j lang package, and that's then imported into your class. And because your student extends that human class, it gets some things. So I'll just go over here to IntelliJ and look at the student class. It extends human. Here, I'm going to put that off the speaker and put it in my ear so it's not so damn loud in the classroom. So in IntelliJ, if you have built your Maven project, IntelliJ ought to be able to navigate to the source code, because it downloads the source code for the human class, and so then you can do that either by command clicking or control clicking, or you can use Control B, Command B. Oops, you used to be able to. There it is. Great. And human is a pretty simple class. This is whole hierarchy that you can see in the lectures, where you have mammals and animals and things like that. Actually, I think there's a way to view the hierarchy. At least there used to be. Let's see here. What is it? If you hit Shift 3 times or something like that, view. No, what is it? Actions. View hierarchy. Yeah, hierarchy. Nope. Coming under diagrams. Oh, here you go. Type hierarchy. Code hierarchy. So what's that? Control H. It says. Let's try that. Control H. Oh, yeah, here you go. You can see the class hierarchy over here. Neat. So you can see that you got the student, and that inherits from human, which inherits from mammal, which it inherits from animal. So IntelliJ is telling you this. I don't know how important that really is, but I just wanted to show it off as this thing that can be done. Anyway, as you can see, every human has a name, and that every human says hello. And this is then a method that is overridden from animal. And so all animals say something, but because animal is abstract, we have a method that says everything, but we don't know exactly what that says. It's up to the implementers of that class to provide implementations of says. So for instance, you have a duck and a cow and an insect and things like that. Oh, a turkey. What does a turkey say? Gobble. Yeah, good deal. And turkeys have names apparently too. So anyway, that's just a brief tour of the class hierarchy. Let's just close all those other tabs. Don't think I need all those right now. Okay. So that's what the student class, the human class is all about. And the student, actually, we can look at the source code in IntelliJ. It's probably easier to read. Student has this has a constructor which takes several arguments: a name, an array list of classes, a GPA, and a gender. It's got this thing called a documentation comment, a javadoc comment, which we'll talk about more later in class when we talk about how to document your code. But essentially, this is a special kind of document that precedes a program element like a constructor or a method or a class declaration. As you can see, it's got one up here. They start with /**, and there's a tool called javadoc that will extract these comments and generate documentation for your classes, for your API based on them. So that's a good thing to have. And then the student class overrides the says method so that all students say this class is too much work. I think I implemented that last time. And then, it's also got a toString method, which overrides the toString probably from object. Oh, no, it's from animal. That's good to know. Because as we'll see that it says something special. And then it's got a main method, right? And so the main method is where program execution starts, and all main methods are public, static, and have a void return type, and they take an array of strings, which are the command line arguments that are passed in from the command line. So this is the skeleton. This is the beginning of the student class. And so I've got all that here in the assignment. We've already seen how we can use Maven to build a project. I'll just go over to my command line here, and there we go. Right, and so we can say Maven W, which runs the Maven wrapper, and we can say clean, which will delete all the artifacts for the project, and then verify. Sorry, we'll just do that here on the screen. Maven W clean verify. And so when we do that, that rebuilds the entire project. So it will compile all the source code. It will it'll run the unit tests. It'll build the executable jar file. It'll run the integration tests, and then finally make sure all the integration tests pass. That's what the verify phase does. It does build all the project up into and including making sure the unit tests pass. And good, it was successful. Now we want to run that main method, and remember the main method, what it does right now, just prints to standard error missing command line arguments. When we run that, and it's the target, it's the jar file it's created in the target directory, and it's called, student version number .jar. We run that, and it says missing command line arguments. Cool. Now, what we want the project to do ultimately is the following. So when you run the project and you give it arguments like Dave, Mail, 3.64, algorithms, operating systems, and Java, it should print out the following output. It should say, Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. So this behavior right here is ultimately what we want our program to do, is to print out this, which, by the way, this is the text that is generated by the toString method of the student class. So this is what we're supposed to implement, right? We're supposed to implement the student object that has a main method that will parse the command line, create a student object, and print out its toString accordingly. So that's the the assignment. That's what the functionality that ultimately we want to implement. And that's what we'll be doing tonight. Just like all the assignments, there's some notes here about error handling. So make sure that your program exits gracefully. So you shouldn't see any stack traces. We shouldn't have uncaught exceptions. There should be an error message that explains what's going on or what went wrong. And so make sure to do that. Now, I used this program for many years as sort of a demonstration program and things like that. And I always, up until a couple of years ago, I modeled the gender as Boolean, and true being male and false being female, which in hindsight was wrong. But I didn't realize it at the time. I didn't really understand the impact of that particular choice of modeling the gender until a student pulled me aside at the end of class and told me a story about how they responded and how they related to this project. We had a really great discussion, and I really appreciated it. It was something that really opened up my eyes and made me understand something about how we represent in software things like gender, sexuality, and race. So Trina provided me with a statement here that I'll let you read on your own. But my big takeaways are the following. When you have something like a piece of software that restricts a choice like gender, where there are many options, but by modeling it with a binary choice, male or female, it doesn't apply to people who want to use your software. As a result, Trina said something very, very profound to me. They said, I can't test myself with the software. I'm like, my gosh, I want people to use my software. I want people to be able to take advantage of what I think I'm giving them. And here's someone who can't, because there's no way for them to test it on themselves, to participate and use my software. So the reaction to this was, I feel like I'm being erased, I'm being excluded. And actually, I want to be completely opposite, right? I want to make sure the software that I write is accessible, is approachable, and is applicable to anybody who uses it. So, based on that discussion, we talked about how best I could evolve this project to be more realistic, and we decided that it'd be appropriate to include a third gender option of other to a student. So the program it takes valid options of male, female, and other for the gender. So I've been doing that ever since, and I still have an incredible amount of appreciation and admiration for the courage that Trina showed in confronting me, a professor who they had never met before, on the first day of class to provide me with this feedback, and in a very straightforward and non-accusatory way. Because it's made an impact on me, and really from both a not only an equity perspective, but just from a usability perspective. And it's made me realize how I can make my software better and more applicable to more people. So that's something I feel it's important to call out because it's a really important lesson that I learned from this project. So that takes us back to our student. So what I'm going to do here is implement this student project. But what actually before I do that, any questions about the student, about sort of what we're trying to represent, or what it is that we are trying to accomplish with this project? Nothing in chat, nothing in the classroom. That's fine. Oh, yep. Question. Yep. We are talking about the students. Okay, nothing, no reason to apologize. I'm sure my explanation was crystal clear. As a matter of fact, you're going to get an opportunity to explore it a little deeper on your own. So let me create a quick Google Doc right here, and let's make a blank one. And we're going to call this test scenarios for the student project. So what we're going to do now is, let's see here, how many people do we have on the, we have 28 participants. I'm going to create some breakout rooms. And what I'd like you to do is the following. I'd like you all to brainstorm some test scenarios for the student project. Oops. And some test scenarios. Probably should prepare this beforehand for the student project. And I'm going to create a table here, and I'm going to have, let's see here, insert table. I'm just going to have 2 columns. We'll have lots of them. And the first column is going to be when the following appears, well, it's provided on the command line. Then we expect the following should be produced. Well, it should occur. Well, then we expect the program, the program to do the following. So, for instance, And let's make this a nice pretty color. So it's a heading, shade of blue. Okay, so that there's the example from the assignment. So when this is provided on the command line, then we expect to do the following, print that whole thing, will print the following, print this to standard output. And it's going to be that. Right, and so that's the case we all know and love. Oops, there's going to be a space there. So like this is the case that we all expect. I'm gonna make that a little bit wider here, so everybody can see it. But what I'd like you to do now is let's take, I don't know, 10 or so minutes and break up into groups and brainstorm other scenarios. And again, when the program has these inputs, what do you expect the program to do? And what this will do is help us explore what the program is going to do and come up with some test cases that we'll implement that'll get us started with developing our project. I'm going to share the link here in the Zoom chat. Make sure everybody can see that. Actually, sorry, let me share that better. Anyone with the link, and everyone with the link is an editor. Done. Oh wait, did I do that wrong? Copy link. Here we go. How about this one instead? Maybe it's the same. Maybe it's the same one. Yeah, it kind of is the same one. Hopefully that's good. Yep, I see some people joining. That's awesome. Okay. Any questions about this little exercise that we're going to be doing? Nope. Okay, I'm going to break everybody out into breakout rooms. I think I'll create like, I don't know, 7 of them. How many people do we have? We have 27. Yeah, sure. I'll do 7. Breakout rooms and create breakout rooms. And I'm going to assign automatically and go. Nice. I'll pause the recording. We'll be back in a little bit. Okay, so hey, we are back from our breakout rooms, and wow, we got some really great stuff here. So I was looking at I was looking over what you were putting together. These are a lot of really great test cases. Before we dive into it, I want to take a couple of moments to reflect on the activity that we just did. So I encourage people who. So I'd like you to tell me about your experience working briefly with people in your breakout rooms, thinking about the test scenarios. What was the conversation like? What were some of the things that maybe came easy? What were some of the things that were challenging? Please raise your hand either in Zoom or on or here in the classroom to let me know what you thought about this activity just now. Easy.
Found it a little overwhelming having everybody typing on the same screen all at the same time. But in general, I felt like our conversation went well. We came up with a lot of the same ideas as other people, but didn't feel like that was a problem. Felt like that was, you know, good that everybody seems to be on the same page.
Yeah. Yeah, it is kind of have. I mean, we do have like whatever 30 people all collaborating on the same Google Doc. I admit it's a little overwhelming, but you can at least see what everybody else is thinking. Yeah, as you pointed out, it looks like a lot of people have the same ideas. Great. Yeah, thank you for sharing that. Jonathan, what were your experiences like?
Hi. Yeah, I think it kind of makes sense to just have like this this dump of test scenarios from all of these people, because that's like ideal, right? Like we have all these different ideas of how things can be tested, and things we might miss ourselves, others will get, and that just builds in like a more robust set of test cases. And I think one that Alana and our group came up with real quick was like, what if they don't have any arguments at all? So I thought that was a pretty good idea there. And yeah, other than that, I think there's like some overlap, and but it was nice to see like all the different ideas that people came up with.
Yeah, totally. Excellent. Thinking outside the box. Yeah, this is a brainstorming activity, right? And boy, I'm going through some of these, and everybody got creative with their emojis, but like, hey, also different notation. Oh, right, a bunch of null and white space characters, and yeah, and so then this is good, and that was the intent, is to give you an opportunity to say, hey, what happens if we throw a whole bunch of different things at the program? Other thoughts people like to share?
This is specifically about the Google Doc, but if it's shared with everyone with a PDX email address, I think it automatically doesn't anonymize anyone. So we'd be able to
interesting, because you're all logged in.
who's making the changes.
So how can I do that? Let's see here. Share with.
So you change it to restricted.
Oh, but I'm not logged in as my PDX. That's why. Sorry.
Well, that would explain
That's
it.
probably my personal Gmail. Good call though. Oh, I don't know. It's kind of like having like anonymous cheetah and anonymous Aruba or whatever that was.
Yeah, it's cute. I just thought it might be
Auroch,
easier to figure
yeah.
out where our group members' cursors were.
True. Fair enough. Yeah. I wonder where they're anonymous. Yeah. Mm. Yeah. Yeah, so what Alex was pointing out is that, by going through this, by seeing everybody else's, he got to, see where things were similar, where things are different. He was like, oh, well, I thought of putting like unexpected input in there, but boy, I never would have thought of emojis, right? That kind of thing. Excellent. Great. Okay, then. Any final thoughts before we start implementing some of these? Okay, we'll come back to this in just a moment, but first I want to talk about testing. So let's go to IntelliJ. So we talked about our student class. So our student class is the code that we're writing, is the main code for our program, right? It's got all of the logic, it's got the methods, the behavior, and it has the main class, which is what the user interacts with, right? The user interacts with, the main method. The user interacts with the main method by running the command line program and sending it program arguments. But in our student project, we also have some tests. We have the student test, which is a unit test. Now, we saw some of this last week, and a unit test is all about testing a single unit, a single programming unit. So a class and the class and its methods, maybe just a couple of objects interacting with each other, but not many. And so here we were, we tested the logic of like the get name method. Pretty straightforward, but we made sure that when we created a student named Pat, that the name of that student is indeed Pat. Now, I mean, this may seem obvious, and yeah, the implementation is really easy, but this is a good place to start, right? Because what tests do is tests codify the assumptions that you make about your program, right? When we write our code, we assume that it does something. And instead of just trusting that it does the right thing, it's much more powerful to implement a test that verifies that. That way you can make changes and make sure, and so you can safely make changes and know that all the assumptions that you had before then are still true. And this is how you find bugs early, right? Is that you run tests. And having automated tests, you can run them so much faster than you can manual tests. So you don't have to retype everything out of the command line when you can just run a test to do it. So unit tests are all about testing the logic of the code itself. Now, the other kind of tests are called integration tests. And those are often a different directory called IT for integration tests. And here we have an integration test named student IT. And now integration tests conceptually test the integration of multiple classes, multiple modules, multiple processes. And it usually involves things that have like big side effects, like writing to a file, right, processing to a database, making a network connection to a REST API, or in the case of the student project and in your projects, calling the main method. Now, the main method is the user interface for the student class, and it takes in program arguments, and then what does it do? Well, it writes things to standard output into standard error. And you want a test to be able to perform those operations, a test that will send in program arguments and then verify that the right thing, that the expected thing is written to standard output and standard error. So for instance, here in my integration tests, what I do is I validate that invoking the main method with no arguments will print missing arguments to standard error. Now, normally, when you write to standard error, that actually writes to the standard error. And how do you capture standard error in an integration test? Well, I wrote a little framework to do that. And the way it works is that you call this invoke main method. And the invoke main method takes a class name, and so then you'll learn in the reflection lecture that there is something called a class. That is a Java object that represents a class. And so when you say student.class, that is the class for student. And then it takes an optional number of arguments, in this case 0, because you're invoking it with 0 arguments. And that returns this main method result object. And from that main method result object, you can get the text that was written to standard error by the main method, and then we can assert that that standard error text contains a string missing command line arguments. Which, if you look at our main method, that's exactly what our main method does right now, right? It prints missing command line arguments to system.error, standard error. And so then that's how the integration tests work. Oops, what did I just do there? That's neat. And so now when you run this test, which you can do by clicking on the little green triangle in the gutter, it'll build the project and it'll run the test. And because you use the invoke main method, this happens every once in a while after you run Maven verify. So if we just do a Maven w clean, then this should be fine. Run this again. There you go. So that test passed because when we invoke the main method with 0 arguments, missing command line arguments was indeed written to standard.error. So now, what we're going to do now is we're going to develop this application based on those test cases, and we're going to write a combination of integration tests and unit tests. We're going to write an integration test to sort of get us started, but then we might find that there are particular pieces of functionality that we want to write a unit test for, because it's really about the behavior of the student class itself and not just the main method. So let's see here. I saw a clean. Oh, there are a couple of questions. Sort/format docs by group. Oh, I see. That's probably during the exercise. Another question here. So to be clear, is Maven clean verify? Okay, is the same as running the IDE run test? Well, no, actually, Maven clean verify will clean your project and then run all of the tests. Here, I can just run a single test, or I can run all the tests in a given class here in the IDE. So it's not exactly the same. What you do inside the IDE is a little bit more focused. I suppose you can do things like run all the tests in a package by doing something like this. Verify build the entire project and does a lot more, and does it with Maven, not through IntelliJ. Hope that answered the question. Nope, no tests found in the package. Empty. Fine. Oh, maybe did I run it? Or maybe if I ran from the package instead of the directory. Oh, and that was test ng instead of regular tests. There we go. Yep, that ran everything. Oh, including the unit tests. Well, that's sweet. Okay, so now let's start implementing some stuff. So I want to go through here and okay. So the first thing I want to do, just sort of get a hang of things, is I want to implement this first test case. This is kind of the ultimate test case. This has a lot of functionality in it. So what am I going to say? I want to encode that test scenario in an integration test. It's going to exercise the main method, and I want to say, okay, so at test void Dave arguments to main method print description of Dave. So what I'm going to do is I'm going to call invoke main, and I'm going to invoke the student class, and then the arguments are going to be this stuff right here, although not with the emojis. So I'm just going to paste this in here. Oh, look, it's got emojis. Well, that's so neat. The first argument is Dave. The second argument is male. I'm going to get rid of those emojis. Third argument is that. Then you've got these, which are the arguments after that. Because I'm not on the actual command line, I don't need to put I don't need to escape those quotes. So now when I invoke this, I'm going to get here, I'm going to get a main method result. I'm going to introduce a variable for that, call that the result. And then, so when I invoke that, I'm going to assert that result dot get text written to standard out, because what happens when I provide, or what do I expect to happen when I provide these arguments? Then this big string here is written to standard output. So equal to, I may just say contain string. It might be some new lines or something like that in there. Let's see here. Dave has a GPA of 364 and is taking 3 classes, blah, 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 blah. He says this class is too much work. Yep, that's what I expect to happen right there. So what I've just done is I have encoded this test scenario. Let me make it a little bigger so everybody can see it. I've encoded this test scenario here in the first line in an integration test. And so then, I'm going to run it. I expect it to fail. And let's make sure that it does. It most certainly does, because it said, hey, I accepted this big old string here, but I got nothing, because it's true. I wrote nothing to standard output. But this is okay, right? Remember the video with Uncle Bob and the silly hat and everything like that? What's the first color? Red, which means the first thing you do is you write a failing test. And now I've got a failing test. And now this test, in order to implement it, I've got to, or rather to get it to pass, I've got to implement the entire project. So this is probably not a test that I'm going to expect it to have passed right away. Instead, what I'm going to, so I really don't want to run it every time that I run all my tests. So what I'm going to do is I'm going to, it's not ignore, what is it called now? Disabled. I'm going to mark it as disabled, meaning that I still want the test to compile and everything, but I'm not going to run it, right? So when I run all of the when I run the entire class, it says that, oh yeah, I ran the first test and it passed, but it ignored one of them, and that is the big old one because that doesn't pass yet. Okay, well, cool. So we've got the ultimate one, and that'll be good. We can come back to that every once in a while, see how close we're getting. What is the next test case that we should implement and then make pass? Like, what is the simplest test case here? Nothing. So, although isn't that kind of what this is? So nothing by nothing, 0 arguments. So I actually think we already got that one. That's good. Let's see here. Oh, great question from Alana. Is there a reason why we're using the integration test for this and not the unit test? Yes, there is, because we are testing the main method. You can't test the main method with unit tests because you have no way of capturing standard.out, right? You don't have standard out. You can't, if you just run it from the unit tests, the output will be written to standard.out, and there's no way in your test to capture that. Instead, you need to use the invoke main framework, which has some magic to capture all of that for you, so that you can then assert that standard out contains the stuff that you expect. It's a really important difference. However, there will be some stuff, I'm pretty sure, in here that we will use unit tests to test first, and then make sure it works in the integration tests. Okay, so we already have like 0 arguments. What's a simple one? Okay, no arguments is there. GPA cannot be characters, too many arguments. Just Dave, well, this one seems pretty simple, but we don't have an expected case. So, okay, so if all you have is Dave, then what should it do? Okay, so not enough arguments is printed to standard error. Okay, so let's write a test for that. So let's see here. We can call it only name prints not enough arguments. Oops. Arguments to standard error. Now you'll notice that I have these like really long. I mean, I have a sentence for a method name, and I find that this is it expresses the intent very clearly, and so then for me it's worth having like a big old method name that clearly states sort of the given when then. So here we're going to invoke main. We're going to with student class with just Dave, and we are then going to make a variable here, and we'll call it results, and then we're going to assert that result result.get standard error contains string not enough arguments. Okay, there's going to be that test, and so when we run it, oops, it's going to fail. Yep. Now we need to make a pass. So let's look at the student here. We need to augment the main method so that this test will pass. How do we do that? Any ideas? Nope. Okay.
If the length, the args is 1, then we don't have enough.
Yes, let's give that a try. I like that. Not enough arguments. Oh, okay. Alex says, well, less than 4. what are the pros and cons of it should be if it equals 1, if it's less than 4?
We're not going to be able to do test-driven development on the next 2 if we do that now.
That's a very good point, Tacey. So sorry, that was Tacey, wasn't it?
Yeah.
Yes, it was. Yep. Yes, one of the so remember, here again, the silly hat. The whole idea is the first thing you want to write is a failing test. And if you implement your code to say less than 4, well, then when I just have Dave and or I just have the name and the gender, it'll automatically pass. And that's not really what you want to do. And this is one of those discipline things you need to have with test-driven development, which is to go in baby steps. I know it seems at times you can be crawling, but it helps you in the long run because you don't implement code that you haven't tested yet, or rather, you don't implement code unless you have a test for it, which means that you'll never implement code that you don't need. I know from experience, I've written so much extra code in my career that I didn't really need because, maybe I'll need it later. I think I'll need to work this way. Nope, write a test for it. And if you always start with a failing test, you'll only write the code that you need to write, no more, no less. Nice. Yep, add error handling in main. Okay, so let's give this one a try. Dave and actually, sorry, that was the wrong one. And actually, I want to say not just contain string. I want to say that it's equal to that. Import that from mattress equals to, and then I think I'm going to need a new line there because I do error.print line. So now let's run this. Oh, and look what I found. It says expected not enough arguments, but was not enough arguments, missing command line arguments. Right, because there's a bug right here. Because, I always print missing command line arguments, even though I had enough. So let's fix this. And also, actually, would I have caught that? No, I don't think I would have caught that up here because, again, my assert that wasn't very smart enough. It just said contain string. And really, this should also be an equal to. Right, so if I run this, so this test here wasn't very good because it didn't catch the fact that I was, actually, I guess it probably would be okay because this one would have only printed missing command line arguments, but this one still fails.
You're also
because
the end of arguments in main.
So what was that?
You're also missing the S at the end of not enough arguments in main.
Oh, thank you. Good deal. This is why pair programming is so awesome. Okay, so there's that bug, but also the fact that we print missing command line. We print missing command line arguments regardless. So let's just say this: if args.length equals 0, then we want to print the missing arguments. Else, if args.length equals 1, print not enough arguments. Now let's run this one again. That one's happy. Now let's run all of our tests to see how we're doing. Nice. Okay, now we have passing tests. This is what test-driven development looks like, right? You start out with your test cases, you go for the simple things, and then you add a test, you make it pass, and now we refactor. I don't know if there's a way to refactor here. We could use a switch statement, but I don't like switch statements. Question came in on chat. Why do assertions not need try blocks or need throw clauses in the method signature? Well, we aren't throwing exceptions here, or at least not yet we aren't. So I think that's why. So assertions, or are you saying why don't we declare that we throw some sort of exception when the assertion fails? Because in fact, we want if the assertion fails, we do want that exception to be thrown because then the JUnit, the J. Okay, great. So we're not sure how Java knows how to handle the assertion failures. Excellent question. So if you look at the implementation of the assert that method, if the assertion is false, so when the text written to standard error, it does not equal missing command line arguments, then it's true. An exception is thrown by the assert that method, and it is the JUnit framework that is running the test that catches that exception and then reports it as a failed test case. Which is fine, which is exactly what you want. So here, so not all exceptions are bad. Exceptions are just part of a method signature. It's how a method expresses that something has gone wrong or something unexpected has happened. Right? When you look at a method signature, what do you have? Well, you have the name of the method, you have the arguments to the method, and then you have the return type of the method, and you have the things that it throws. And so this is all part of the signature, all part of the contract that method provides. So, the assert that method, well, I don't want to decompile it. I don't have source code for it. That's super weak. It doesn't say what kind of exceptions are thrown there, but you'll if you go and look at the source code, you'll see that when the matcher doesn't match the actual result, then an exception is thrown. A special ham crest exception or JUnit exception or whatever is thrown that the JUnit framework, which is running your tests, catches and handles appropriately, meaning that it records the fact that the test failed. Yeah, great question. Okay. So I've got some passing tests, and one of the things that I like to do, I like to commit early and often. So I've got these 2 changes here, these 2 files that have changed, and I'll just commit these by saying added some basic integration tests for the command line parser, or for the main method. Main method of student. Okay, question, yes. Okay. Ooh, good question. So the question here is, hey, I was writing a main method and I had a check args function that probably a method that took probably like the array of strings, and then what did it return? Or what did it do? Like threw exceptions if something was invalid? Okay. Yeah. Yep. Ah, okay. Right. So it takes the array of args and returns whether true or false, whether or not it was valid, right? Well, if that method doesn't interact with standard output or standard error, that is a great candidate for a unit test. So there is a method that I would say, yeah, we should write a unit test for that because it doesn't interact with standard error and standard output. Here, because we are interacting with standard error and standard output, then we do have to use an integration test. But I wonder if there's a way to refactor that. There probably is. What we could do is replace this logic right here with a method that returns, I guess, an error message to display. Well, you know what? Let's give that a try. That's very interesting. So here's what I'm going to do. I'm going to do the following. So this might be a nice refactoring. I'm going to introduce a variable here called message. I'm going to call it error message. And I am going to split that in declaration of sign. I'm going to move that up here. I'm going to move this down here. And then I'm going to replace this with error message equals not enough arguments. And I'm going to say otherwise, let's say error message equals null. And I'm going to say if error message doesn't equal null, then print it out. So I've made this refactoring, and so the next thing I'm going to do is I'm going to rerun my tests just to make sure I haven't broken anything. Right, this is a good thing to do after you refactor some code. I made my change, good, everything still passes. And okay, now what I'm going to do is I'm going to take all this logic right here, and I'm going to extract a method. So I'm going to say refactor, extract introduce method. and I'm going to call it validate arguments. Oh, I don't need to pass it. Why is it passing an error message? That's weird. That's dumb. Okay. And I'm going to say, I'm going to fix this code here. It probably wasn't as smart as it could have been. So I don't need this anymore. And now I'm going to just take this. I'm going to get rid of that. And I'm going to make a local variable for this. It's going to be a string error message equals null. Okay, so now, yeah, I move this into a into its own method. I'm going to rerun it. Still does the right things there. You had a question? Oh, okay, sure. He was like, okay, yeah, do we really need this error message variable? I suppose we don't. We could just say this. We just say return this, and then we can say return this, and then we can say, I like to have an else block here because it just makes it super clear. Yeah. Well, now, okay, and so then, oh, I guess we don't need this anymore. Oops. And now when we run it, we've got that. Okay, cool. And now we've got a method that doesn't interact with standard out or standard error. And so now we can write a unit test for it. So let's go do that. And then we can say void, let's just say, 0 arguments returns missing command line arguments. And so now we can say the following. We can say, assert that student dot validate. Oops. Oh, I need to make it package protected so that you can see it in the test. So we'll make it visible for testing. Validate command line validate arguments with nothing. So let's make this variable arguments instead, so we can send in and that. Oops, why is it complaining about? Oh yeah, variable that, and we say equal to missing command line arguments. Nice. And now when we run that, ooh, it passes. Well, nice. Now we can test this logic using unit tests instead of integration tests. It's a little bit more straightforward, and we can probably develop them a little bit faster. I like that. That was a good idea. And so now we can have our command line parsing there. Okay. Yeah. If it works, there's nothing wrong. So basically, the question is like, hey, was this the right thing here? Because that's what he did for the project. The answer is yes. I mean, ultimately, if you've got something that works, I mean, it functions as you expected, and it has the required code coverage that we'll talk about later, then yeah, that's fine. Yeah, and let's try this here. I like this approach. Something different. A question from chat: how many tests / under what circumstances do you want us to test? Will tests be turned in with submit.sh? We'll talk about all of that later in class, so stay tuned. Yeah. Yep. Nice. So let's commit these, and we'll say refactored command line validation so that we can write unit tests for it instead of integration tests. Neat. I like my commit messages to say what I did and why I did it. So it's usually like, I did something so that I could get some results. Nice. Oops, I spelled arguments wrong. Rename to our argument. Yeah, this one right here. Nice. Okay. Well, let's see here. What's the next thing we need to validate? It's probably, what's the third one? Let's see, actually, let's check off the ones that we've implemented. Just so that I know. Let me just quick highlight that in yellow. No, that's not what I wanted. Fill it with yellow to say it's implemented. Yeah, question? Yeah, so the question is, hey, things are going by pretty fast. Yep, it'll be the recording. I also just push it to GitHub. So like if you go and look in GitHub at my summer 2022 repository, right? And here's the change that I just made. And so then you can look at that and you can see the change there. But if you just go to my student class, view file, and just go to the main branch. Here's the latest version of it. You can check it all out here. Yep. That's why I push. Yep. Right. So that shares it with the world. You are welcome. Okay. Let's see what the next. Oh, here's a good one. Let's see here. Dave mail 3.64. Number format acceptance thrown or invalid parts were GPA string mail. Actually, is that right? I mean, I think the third argument is the GPA. So this is actually a valid test case? So what was that? Yeah, I think GPA is so. Right. So actually, let's go back to the assignment. Let's just make double sure. Yeah, the gender and then GPA. So yeah, you know what? I don't. So let's see here. Let's we have the let's just quickly let's just quickly implement another one. I guess only one argument returns. It says not enough arguments. I don't know if that's really the behavior that I want because it's not very specific. I think I want to say instead missing gender, right? Sorry, that's the second one, right? Name, gender, yeah, missing gender. So I'm going to say assert that student.validate arguments with just name equal to missing gender. If I run this, it failed because it's saying not enough arguments. So I'm going to replace this with missing gender. Run this again. Oops, what did it like? Oh, capitals. Important stuff. Yay, that passed. Okay. Yeah, question? Yeah. Yep. Yep. Great. Yeah, the question is, hey, at what point do you go from like a unit test to an integration test? Well, I guess it's maximize the code coverage with unit tests because they're fast to run. It's only when you absolutely must write an integration test or write an integration test. So, I mean, I like the integration test because it really helps you understand like the big picture of the program, right? The actual user input, but all the guts of the program, all the inside, the logic and stuff like that, write unit tests for that so it's faster. So I guess it's only like, yeah, when you've got to validate that something is, written to standard error that you absolutely must have an integration test. Good question. Okay. Let's see here. Okay, I made that change. I think this will break something here, so I want to run my test again, but let's just be sure. Oh, yep, some things failed. Only name prints not enough arguments to standard out. It does not. It should now print missing gender. Let's run these tests again. Nice. Okay, so now we have that test. Now let's go write a new test for, let's see here, only a name and gender returns missing GPA. Okay, let's just copy this one and make it easy. And actually, I'm going to do an import here, a stack import, so that we don't need to have that student prefix. So the first one's name, and the second one is gender. And then it's going to be, when you only give it that, it's going to be, we want to say missing GPA. Now, if we run that, notice I'm using keyboard shortcuts here, but you've got the little pop-up at the bottom of the screen that tells you what I'm typing. It's saying, aha, I expected the string missing GPA, but it was null because it's true. I returned null there. So then let's add another else block. Else if args.length equals 2, say return missing GPA. Nice. Okay. Now let's see here. What's next? Okay. Well, so then what happens? Let's go back to the test cases. Do we have? Okay, so this one didn't seem right. This was like, yeah, this doesn't seem like the right behavior here. That actually would be something like, sorry, what? Well, we haven't gotten to actually parsing the GPA yet, and maybe we should, but we don't have a valid command line. We don't have a valid argument yet, command line yet. So, so like, what happens actually with this, with that program input? I don't know. Maybe we have it tested. Maybe we have it here in a test case, but I think someone said, hey, if we switch these two, then it makes sense. Okay, that one does. Okay, let's get to that one after we figure out. So what happens here? So if we have name, well, let's have a valid name. Let's have a valid gender. Let's have a valid GPA. What happens here? Is this valid? That's all you have on the command line.
Yes.
Yes. Why is that? Why is that valid? So it should be a null value.
Because the student can be enrolled in no classes.
Ah, okay, sure. So student enrolled in 0 classes is valid. Nice. Okay, so let's test that out. Nice. Okay, that one worked. Okay, good to know. We should, yeah, we should keep that valid, or we should do that. Okay, great. Okay, awesome. So okay, we've got this. Let's check these in. So we'll put in added more command line validation. Where do you want to go next with this? Like, what's the next test case that we want to get passing? Invalid range. Oh, okay. Okay. So invalid range here. I assume that means GPA range. Pretty good. You said regex for something like what? Valid character input for what field? For what thing? The name? The whole command line? Well, so like what would be an example of like an invalid command line? In underscore? Can people's names have an underscore? Well, I guess gender can't have underscore, and neither can. Okay, so yeah, let's start putting some more invalid input in there, and let's do the gender validation, I guess. So let's see here. Let's test for. Let's see here. So let's see here. Invalid gender returns invalid gender. So assert that validate arguments. So let's see here, Dave invalid, and let's just give it a real GPA. So this should then be equal to invalid gender. How do we say unrecognized? Yeah, I don't like that word invalid. It kind of reeks. Let's replace that with unrecognized. Recognized. Oops. I think there was a way to do that anyway. Unrecognized gender. Okay, so now let's run this. Okay, so that returns null. Okay, so let's see here. So what do we need to do here? We need to realize that the second argument here is the gender. Okay, so well, we're here. So let's see here, like right here. I mean, so then we want to check the gender. So string gender equals args. What is that? That's 0, 1, 0, 1. So here, that's the gender. And then maybe want to write. Well, so maybe so how do we want to do this? We want to say.
This could be a good time for regex.
Ooh, good time for regex. Say it's always a good time for regex. So what do we want to say? We want to say then yeah, if it matches male or female or other, then it's okay. If it doesn't, issue the error.
Yeah.
I'm liking that because I don't have tests for it. So maybe like. So should we write the code first and write the test later? I want to write the test now. And as a matter of fact, you know what? I don't want to have to like send in all of the arguments. So here's what we're going to do. Let's have a new function which is validate gender. And so then let's see here. Yeah, there's some stuff here I don't like. I think we're going to refactor this later, but that's okay. Well, okay, yeah, because I was going to say then instead return validate gender and then the gender, which is args1. And then, yeah, this can return null if everything's happy. So, And then, okay, so let's write some tests first for void other is valid gender. So assert that validate gender. Oh, I need to make it visible for testing. Visible for testing. Other is null value because that's valid. Okay, and right now I'm just going to return null. Actually, no, I'm going to return invalid gender or unrecognized gender. Just so I can see it fail, and then I'll make it pass. Yeah. Implement Java enum once, decided to switch dictionary. Okay, can we do enums? Oh, questions here. Can we do enums? Yes, you can. Yeah, I kind of like doing an enum. But let's get this stuff, yeah, working first. Well, yeah, boy, I kind of like this. So if gender equals other, yeah, then return. Yeah, also returning null is kind of hokey, I have to admit. So if we, yeah, I like the idea of using an enum for gender. Although if we look at the constructor for student, it takes a string. We can change that though. Yeah, let's do that. Let's have an enum. So an enum, I guess what an enumerated type is. It's basically like a type that has only like a preset set of values. So let's do that instead. So let's have validate gender return an enum, which is a gender. Not that one. We'll make our own. And we'll say create enum gender, and we'll put it here in main. Do I want? Yeah, sure. I'll have it out there. So I want to add that file to Git, and so we'll say assert that validate gender of other is equal to gender dot other, and then we'll create a enum constant other. And now this fails because we want this to be gender.other, and we'll have it return. Well, here we'll have it return null, which isn't exactly right. But we'll fix this later. Okay. So let's do that. Okay, cool. So let's duplicate this. So we'll build it out for male and female also. Oops. Female is valid gender. Yeah, question? Yeah. Sure, I'll show you right now. And we will create a enum constant. Let's go take a look at it. So an enum looks a lot like a class, except that it's public enum gender, and then it's got, these are the values that I can have. So basically think of it as a class with only like 2 instances. One represents female, one represents other. Yep, that's what it looks like. And so now if I run this, I think it'll fail. Yep, expected female, but was null because we don't have this. So else if gender equals female, oops, then return gender dot female. Oh, why doesn't it? Oh, somehow got an extra. There we go. Cool. Okay. So we handle case for incoming gender string. Incoming, say more. I don't quite understand what you mean by that, Kyle. Should we handle a case for the incoming gender string?
It says
uppercase, lowercase.
sensitive in the assignment.
Yeah, so in the assignment, it says that the gender is case insensitive. So yeah, let's do that. So let's say here, we can have female. And we'll run this. Nope. Okay, so then we say equals, ignore case, female. And we'll run that again. Nice. And we'll want the same thing with other. Other, and then we want all uppercase, other. And then we'll run that. Watch it fail, and then we'll watch it pass. Always want to write a failing unit test first so that we can be sure that we understand that, yes, the functionality really isn't implemented. You can't do it 100% of the time, but you should always try. So it resists the urge to do like, oh, okay, I know I need to do it for female, I'll do it for other also. Nope, gotta resist that urge. Okay, now let's see here. Let's do male, and here I don't know. We can. This seems a little silly at this point, so. Male, oops. Male, add that constant, watch it fail. Nice. And then male. Oh, male, well, they'll both pass now, but that's okay. We're gonna kind of, wash, rinse, repeat at this point. I'm pretty confident I've got the right thing going here. But we got a test. That'll tell us, okay, good. Okay, so now we've got that validation right there. Oh, and then we've got this test right here. This one still doesn't pass, I bet. Okay, accepted unrecognized gender, but was null. So now here we want to say gender equals validate gender args1, and then if gender equals null, then return unrecognized gender. Try this. Cool. Okay, that worked. So now let's run all the tests in our student test. Everything passed. That's awesome. Let's run our integration test just to double check and make sure, because it's pretty inexpensive to do so. Run all those too. Yay. Okay, everything passes. Okay, now we have the gender validation stuff. That's pretty cool. Okay, so then validate the gender value provided on the command line. Nice. Okay, I think it's time for a break. Gosh, it's already 7:13. So we've been going for like an hour and a half, if not more. Okay, let's take 10 minutes. Let's take 12 minutes. Come back at 7:25. We'll resume recording. Okay, hey, we're back, everybody. And need Zoom to disappear here. Please disappear. Obnoxious. Floating meeting controls. There we go. Okay. Well, so in the beginning of class, we did a bunch of test-driven development for the student project, and I was thinking about it just now, and I'm not happy about the way these validation methods work, because they return null, and that seems like super hokey to me. That's not a very good practice. And as a matter of fact, I think we're going to get ourselves into trouble with like this validate arguments by returning this string, because at some point we're going to want to create a student object, and I don't know when we're going to do that exactly. So what I think is ultimately I want is validate arguments to return a student just the same way that validate gender returns a gender. So I think I really want to call this validate student. And so then I don't want to be returning these strings as the return value. All of these strings represent an exceptional situation. Something's gone wrong. And so then I think we should use exceptions instead of strings in these cases. So I'm going to do a little refactoring now, and I think what that will do is, well, first of all, make the intent of the code more clear, but also let us do some better testing of things. So let's start with refactoring validate gender to return an exception when you have an unrecognized gender. So okay, not return an exception, throw an exception. So unrecognized gender throws, I will say throws unrecognized gender exception. And let's see here. So instead of saying that assert that it equals, wait, oh, that's validate arguments. That's, oh, did we not have a validate gender of, oh, okay, interesting. Okay, well, let's just change this. So instead of saying validate arguments, let's just have validate gender here, and we'll just have it of unrecognized. And instead of saying assert that, we'll say assert throws. Now, assert throws, I need to import it first, and we'll do it right there. This thing, you give it the type, you give it the class, the dot class, for the exception that you want to that you expect to be thrown, and then something called an executable, which we use lambda for, to have the code that actually we expect to throw that exception. So we expect that well, we'll a new exception type. Yeah, question? Sorry? I did start the recording, but let's just make sure I see. Yep, the recording has been started. Yep, I remember the nice little lady telling me that the recording was started. And so what we're going to say is we're going to assert that an unrecognized gender exception. So we're going to create something called an unrecognized gender exception, and we're going to create it in the student class. This will be like an exception declared within the class. Unrecognized student exception dot class is thrown by the code. We need a lambda here. Validate gender. And so that, I think, is what we need. Yep, it's complaining that there is no such thing as an unrecognized student exception. So we'll create class. We'll create class right there. It's still telling me there's a problem, and it's saying that add import. Well, that's not exactly what we want, but okay, that'll work. What does it say? Create method assert throws. No. It's probably what it's telling me is that this is not extended exception. Extends exception. Why is that highlighted there? It may be static. We'll make it static. It doesn't need to be public. It can just be package protected and make it visible for testing so that we know that's there. Okay, so now what this is saying is that when we call validate gender with a string unrecognized, we expect that an unrecognized student exception is thrown. So now when we run this, we should fail, right? Because we haven't actually done that yet. Nice. Oh, expected. Let me hide that. Expected unrecognized student to be thrown, but nothing was thrown, which is true because this returns null instead. So instead, what we're going to do is we are going to throw a new unrecognized student. Oh, that's totally named wrong. Sorry. Let's rename that to unrecognized gender exception. What doesn't it like there? Unhandled exception. Oh yeah, right. Because then we need to declare that it throws that 6 related problems. Gadzooks. Oh yeah, because we just added that all over the place, and that's fine. So so because I had a return extend exception, it's now required to be thrown in all of these places. So it declares that it's thrown. And you know what? I think I'm okay with that. I think I want to make this incredibly clear that this exception might be thrown. So now what we got to do is we've got to we've just got to basically add this to the method signature for all of these problems right here. Okay, so now it's all of that. And now what happens when we throw it? When we run this? Is it happy? Oh, oopsie. Oh yeah, there's another place that we call it. Now here, we don't need this anymore. Well, or do we? Yeah, we'll get back to that, I guess. Okay. 4 related problems. We probably have, we probably have other places where, yep, where we need to add that exception now. Interesting. Now validate arguments might throw that. Nothing wrong there. Okay. This is the one that fails. Oh, once more was, oh yeah, and then our main method. Oh, interesting. Well, for the time being, I'm going to do that, but that's not ultimately what we're going to want to do. Because remember, main methods should not throw exceptions. They should catch them instead, which, well, actually, yeah, I know I should do the right thing now. Shouldn't I? Sorry, what was that? Yeah, so I should put a try catch around this. Surround with try catch. It catches that, and instead I should say system.error.println. I guess the get message from this. I guess, I don't know. Oh, and probably this then should go up here. I'm gonna fix all this eventually. So then, yeah. But right now I kind of want to just get things to code, or the code to compile. And so this is the way you code, right? You write some stuff, you try some stuff, you refactor things, you try out new ideas. Okay, that thing passed. Did everything else pass in here? Nice, all that passed. See how fast the test ran? I just got 13 points of validation in like less than a second. Let's run the integration test. These might not pass. I don't know. Let's see. Wow, it did. Okay. That's kind of interesting. Yeah, that might be okay. Cool. Okay, so now, oh, let's go back to the student. Student. And I want to go back to the student test because I want one more thing. Oops, the integration test. That new one that I just added. Where'd it go? Assert throws. One more thing that you can do here that I really like is that assert throws actually returns the exception that was thrown. So I can then put this into a variable called, I'll call it EX for exception. I'll make it a little bit easier to read by putting it in a separate line. And now I want to assert that I'm going to, I want to, well, let's see here. I'm going to say get unrecognized gender equal to, and I'm going to say this string here. Containing block. Yeah. Recognized equal to unrecognized. See, what I can do here in the exception is I can catch the bad data and then package it back in the exception to send it to the caller. And this is nice, right? Now you can get information. Your exception is now much more rich. It's not just saying, oh yeah, some exception occurred. It's like, here's exception occurred and here was the bad data. So I'll create this right here. I'm gonna have it return null for right now because we're gonna watch the test it compiles, but we should watch it fail. Nice. And so I'm going to do then is when I create the exception, I'm going to pass in that gender that was passed in there. And so now I want to add that constructor. I'm going to call it unrecognized because this is the value that is unrecognized. I'm going to store it in a field so that we can then recognized equals unrecognized. I'll put that in the field. And I'm going to return it down here. Nice. So basically what I'm doing now is I'm adding, as I said, enriching the exception. And now when I run it again, I expect that it'll pass because when, so when the that string unrecognized is passed in here, it comes down here, is included in the exception is thrown, the exception is then caught by the assert throws, is returned, and now I can interrogate that exception and make sure that indeed the gender that was unrecognized was the string that I passed in that unrecognized. It just makes the test more robust and ends up testing the right things. Now my exception is interesting. And actually, so now let's do something. Yeah, let's do something more on the command line. So, okay, so now I have this. What do I want to do now? I want to go write an integration test for this. What should happen with what should happen here? So when I invoke with Dave and unrecognized and then a valid GPA, what should happen here exactly? Well, but this is the main method. We don't want to throw the exception. We want to catch the exception and handle it. What should it print to that? Oh, question from Alana. You said you were uploading these files and getting started GitHub. No, it's not my getting started. It's my summer 2022. Here, I think I want to say something like unrecognized gender, unrecognized. Right, that gender that I passed in unrecognized, recognized. I want to say something like that. Let's just see what it does now. So this is, we'll say unrecognized gender is printed. It's written standard out. Standard error. So let's run this, see what it has to say for itself. It failed. It said unrecognized but was null. Oh, that's interesting. So I wonder why that is. Let's go look at the main method. Let's just see what happens. Where's the main method? Blah, 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 blah. Oh, interesting. It's printing e.getMessage. Well, that's not exactly what I want. I suppose I could override getMessage to have that. Maybe I could do that. I wonder if that's probably okay. Ooh, good question from Alana. I'm gonna do that. I'm gonna override getMessage. I'm gonna have it return unrecognized gender, and then this dot unrecognized. Actually, I'm going to say this dot get unrecognized gender. And now I think that'll be okay. Nice. So what I'm doing here is, I don't think it's overkill to have things like a custom exception for this case. This is something that I do a lot. Remember, exceptions are all part of a method signature. It's all part of the contract. And making sure that you have robust and clear mechanisms for expressing when something has gone wrong is an important part of your program, right? You know, if you're a user, certainly while you're developing, if something has gone wrong, you want to know about it. So just like having a null pointer exception, that's not helpful, right? I mean, you know, we look at that, and it's like, it doesn't help me. Then you got to go debug it. Well, this way I get something that's very clear when something has gone wrong. Question, additionally, you mentioned that gender in case is case insensitive. Sorry, it's case, well, it is case insensitive. You can have other. So it's possible for the user to do something like capital F female or other. Would it not be better to just convert them to lowercase and then test that they're valid? Oh, actually, so sorry, it's case. Oh, well, okay, so I don't need to. I'm using equals ignore case, so I don't think I need to convert them to all lowercase. That's basically, I think, what equals ignore case is doing. Alana, do you agree, or is there like a nuance that I'm missing?
I think I just missed when you put those in there, but then if we were actually working with the function while we were running the program, we would use something like 2 lowercase.
I mean, so yeah, what you're suggesting by taking the gender variable and putting it to 2 lowercase and then doing an equals compare, I think that'll work also. I'm just using this shortcut method, which you know, I don't need to think about. And actually, this probably oh no, it looks like, yeah, I don't know, it handles Unicode better and stuff. So there might be some nuances for, you know, non-ASCII characters that I don't know about that it takes care of. Question here? Nope, this is the string, but then what I end up passing in here, like here on the command line, is the string unrecognized. So yeah, I mean, that's a good point. I mean, this is a string unrecognized, so maybe this is like, I mean, I don't know if I said bogus instead, would that maybe maybe make it a little bit more clear? So this should still pass. Yeah, so I mean, that value that then gets passed, you know, ultimately to the validate gender method, to the unrecognized, and then because it's not any of these cases, we throw the we pass that into the constructor to the unrecognized gender exception, which then populates this field. And then when we go call get message, it calls this thing, right? Right, yeah, this is the code, right? Yeah, right. This is what it all does. Yep. And this is object-oriented programming, right? You're creating this object that represents something has gone wrong, and you are giving it some state that said, hey, here's the thing that was bad. And then you can interrogate that state afterwards, like we did in this thing right here, where we get the instance of the unrecognized exception here in EX, and when we call the get unrecognized gender, sure enough, it's the bad thing that we pass in there. So maybe here again, I'll just rename these to be, I'll just use all of them and just call it bogus. And now this should still work. Yep. It's fascinating. It's programming. Yay. Nice. Okay, so I just want to rerun all my tests one more time. What's more with feeling? Are we doing on time? 7:45. I can go for a little while longer. Nice. Okay. So I'm happy with this refactoring. I feel better about my code. This just seems cleaner to me. Instead of like returning the well, and actually let's go do these two real quick. So added an exception to represent, or to signal, I guess, signal an unrecognized gender value. Okay, let's open GitHub now. Okay, because now that I've done this, now I think I want to change my validate arguments a bit, and I want to call. Ultimately, instead of returning a string, I think this is where I want to create the student. That's what we're doing, right? We're taking the command line arguments and we're creating a student from it. So I'm just gonna let's just rename it, and let's just say, and sorry, I'm using the refactor rename. Sorry, rename. So for me, it's Shift F6. I'm just gonna call it create student. From. And I want this thing to return a student instead. And then I'm going to change this code, so it's going to be a lot of different things. But now, right. So now instead of returning things here, I want to throw exceptions. I am going to say, I'm going to say throw new, I'm just going to call it missing command line arguments. You know what? I don't think I need that word exception anymore. Do I need that? I don't need that word exception. Who cares? Okay, I'm just going to put that text in there. And now I'm going to create an inner class here. This is going to be string. I'm just going to call this message. And I have exception. Nice. And now, oops, what doesn't like there? Unhandled exception. Well, I need to add that to the signature. And it's going to have all sorts of problems. So I'm just going to do this a couple more times here. So now, again, I'm using exceptions here for the error cases so that it's clear that this is something that's unexpected. And I think this makes it a little stronger from an API standpoint. And now I don't need to. I don't need to do this anymore, because actually this is kind of dead code, because gender actually will never be null, right? So either you return a valid gender or you throw an exception. It's never going to be null. So I can just do that. And oh, interesting, it doesn't. Well, I'll need that back later, but I'll get rid of it for now. Oops. No, I'm just gonna delete that. Okay, because I mean, eventually here we're going to build. This is where we build our student. Okay then. So I have all of this. It's saying there are 4 related problems, all over the place. What do we got? Okay, here's where we call it in the here. So now, okay. So now instead of saying A, it returns missing command line arguments. Instead, we are going to say we're going to assert that assert throws. And this is going to be a missing command line arguments. Oh, this probably is private or something. Yeah, I'm gonna make it visible for testing. Oh, good question. I made my I made my validate arguments function private because it was trying to enforce abstraction size encapsulation. This means I can't use it externally for unit tests. Do I need to make it public? No, you don't need to make it public. You need to make it package private by having no access modifier on it. And so that way, since the tests classes, so this is in my package is the same as over here, because the classes are in the same package, then they can see the methods and the fields that have no access modifier on them. Yep, and I like to annotate those with @visible for testing to say, hey, wait a second, I made this thing. This thing isn't private because I want to test it. Good question. Okay, so then I made that thing like that, and so then throws missing command line arguments dot class, and then oops, I deleted my call to validate gender. No, validate. Oh, no, it's create student is what it was. Yeah, create student from. Yep. Okay, what is it saying here? Unhandle exception, yep, might call that. Actually, never mind. Okay, so it's going to assert that that is thrown. And yeah, I wish I had a wide screen. Okay, what doesn't it like here? Lambda can be replaced with method reference. Swell, okay. And then this thing is going to is going to create an exception. And then we're going to say assert that ex.get message is equal to this. Okay, so what are we doing here? We're saying, hey, listen, we create student from no arguments, then it's going to throw a missing command line arguments exception. I'm going to do a static import there so it's easier to read. And then it's going to capture that exception and interrogate it and say, yes, I expect that, or I assume that the message returned by that exception is equal to missing command line arguments. And this is just, to me, this is a more type safe, a more natural way to express the error condition here. Oh, another example of exceptions there. I am going to add this to this clause right here. What doesn't it like? Oh, it doesn't have the error message anymore. Well, this is going to be the student eventually, but right now I'm not doing anything with it, so let's do that. I think we can get rid of all this stuff now. Still has 3 related problems. Oh, I got it right here. Oh, I gotta fix all this stuff too. Okay, I am just going to copy and paste some stuff because this is really super annoying. Now we're going to say create student from name. There we go. And now instead of missing command line arguments, it's going to say missing gender. This is one of the things about refactoring. I mean, you have to spend a bunch of time sort of massaging your code and getting it back to, getting it back to life, and that's okay. You get really good at like copying and pasting things in IntelliJ. A lot of the times refactoring will take care of it for you, but sometimes it isn't. It doesn't, and that's okay. At least IntelliJ tells you that there's code that you can remove and stuff. Okay, so now let's see here. Now one related problem. Oh, once more. What is this? Oh, is valid. Okay, so then oh, interesting. Yeah, okay. So then this is still a valid test, I think. Because, well, for the time being it is. Eventually it'll return something that's not null, but we'll just watch that one fail later. Okay, so let's see if this test fails here. This is the create student with 0 arguments. It does. It says expected missing command line arguments, but was null because ex.get message returned null, which maybe isn't surprising because I don't do anything. I don't do anything with that message that is passed in. I just happen to know that there is an inherited constructor here that will take a message. And so I think this is the thing that gets passed as get message. Let's just run the test and find out. Ooh, it does. Good. Now let's run all the tests and see how that works. Yay. Okay. Nice. Whew. More refactoring. So what have we done here? We've gone through and we've changed, we've evolved our command line parsing, our command line validation to use exceptions instead. Now we're still not creating our student yet, and that's okay. We will get there. We'll get there shortly. Let's try to get there next and figure that out. So then let's commit this code and say missing command line arguments. Missing command line arguments. Question I heard, I thought, or was that just sort of an why are we still doing this? Okay. That's all right. Awesome. Okay. So now, yeah, let's actually have the student do something. So let's do the following. Let's have there was that test where we created a valid student. This one right here. So instead, let's have this one. Let's have this one do something. Let's have this. Let's just do this. We will create our student here from the command line. It's called student, and then we will say assert that student dot get name equals to Dave, and we'll just put this into a variable name. Oh, actually, this is, no, sorry, I don't want this. I think I just want to say that here is a not null value. Not null value. It's going to fail because I do return null. So I'm just going to return, I don't know, a new student, and it's got a constructor with a whole bunch of stuff. Well, let's just put in some dummy things right now, and we'll do a new array list. This is sort of in the spirit of getting it to work, and then we'll write a real unit test that does something a little bit more interesting. New array list, an empty one, and then we've got a double GPA. Let's put in a dummy value. Probably not that one because I've been using it in my tests. And then a gender as a string. We're going to fix that. We're going to fix that. Okay. But now this. Actually, I don't want to call this. I call it Dave. I want to call it name. Student. Okay, so this passes now. Now let's actually do something a little bit more interesting. Let's just say, let's just go through and say, can create student with expected name. So I'm going to say I'm going to create a student, and by saying create student from, and the arguments are going to be well, Dave, and then sorry, it was Dave, and then it's the gender, and we'll use a valid gender, and then we'll say a GPA of 3.64. And then this might throw some exceptions. That's fine. And we're going to assert that the student.getName equal to, and we're just going to have this be the name. Right, here's what we want. We want to say, hey, listen, we pass in these command line arguments where the name is the first one. We want that to be the name of the student object that's created. It fails because, well, it's a Dave, but it's actually a student named student because everything I'm creating here is student. Okay, so now let's take a look at this code and see how we can get this to work. We want to start creating a student. Okay, sorry. Let's back up because yeah, I went through that whole thing about asserting a function throws an exception containing a certain text pretty fast. So let's take one more look at that. Here is let's take a look at this one with unrecognized gender throws unrecognized gender exception. Okay, let's walk through this. It's 4 lines of code, but it's kind of hard to read. First of all, we have here is the bogus gender. And we send this bogus gender to the validate gender method. Now the validate gender method is over here in our student class, and this is the thing that takes the gender and will look to see, hey, is it one that we expect? And if it's not, it throws an unrecognized gender exception and provides that gender. If you go to this constructor, it's passed in that unrecognized gender. It stores it in a field called unrecognized, which is accessible via a get unrecognized gender method. Back over here in our text, we call validate gender, and we call it in the context of an assert throws. So assert throws says, hey, listen, I assert that when I call a certain method, I expect that an exception is thrown. In this case, an unrecognized gender exception is thrown. So I make that assertion, and if that assertion is true, if that exception is thrown, this method returns the exception object that was thrown. And now that I have that exception object, I can validate that, yes, the unrecognized gender that was seen in this case is equal to the bogus one that I passed in. A lot going on here, but this is the pattern that you follow to validate that an exception was thrown and the exception contains the state that you expect. No problem for Apollo. Yep, no, I'm happy to repeat that. I'm sure you were not the only student with that question. And thanks for not waiting until tomorrow when I have the recording up to go back and validate that. Super cool. Okay, now moving on to this. Create student. I'm pretty sure this is still failing because my student is always named student. So now I want that student to have a name that's passed in on the command line. So I guess now I'll just do this: string name equals arg0, and then put the name in here. I think that should work. Nice, it does. Okay, so here I'm parsing the command line, and if it's got enough stuff, then I will create my student. Okay. Now I'll just quick commit this. So I'll say pass the create a student with the name provided in the command line arguments. Okay, now let's do the same thing but with gender. And create student with expected gender. We will have just inline that, and here's the gender. We'll do male. We'll say student get gender equal to student gender dot male. Student doesn't have a get gender. Well, let's create one. No, I don't want that to be a string. I want that to be a gender. And let's have a return null just so we can see this fail. Okay, so it was male, but it was null. Okay, we want to have return this dot gender. Let's create that field. Great. We'll need to populate that field. And here's where we need to do some more code changing and some more refactoring, which will probably cause a bunch of changes. We're going to change this, instead of taking a string, let's just have this take the gender. And then say this dot gender equals gender. It says one related problem. Oh, I bet there are more than that. Oh, here's, okay, maybe there isn't. So here's where we created a student before. Instead of the string here, we'll just say gender other. That will be valid. And maybe that was it. And it says there's one more error here. So let's see that one error. Unused import statement. Oh, well, fix that. No, it's not even close class, so I don't know what I was complaining about. Is there an error here? Oh, there is. Oh, okay. Well, here's where we here's where we create the student. So here's where we should have there's that. So maybe we should just inline this. There we go. And that takes a gender. Actually, what was there a gender? Why was it saying gender 1 there? I think I'm going to put this into a variable just to make it a little bit more readable. Here we go. gender. Yeah, I think it's a little bit more readable. Okay, let's give this a whirl and see what happens. See, I think there's this test down here at the bottom that we added. Yeah. Yay, and it passed. Okay, cool. So see what we're doing here. We're building up our code for parsing the command line and creating our student. Okay, it is 8 o'clock. Let's try to think if there's anything else that I want to show you with testing. Because we did that. We are in the middle of TDD for students. Let me show you one more thing, and then it'll be time for a break. Okay, so I think this is enough test-driven development. So, yeah. So, I mean, eventually what we're going to want to do is in the main method, we're going to want to get the student and then print its toString value. And, but we're not quite there yet. Maybe we can, if we get through the rest of the stuff tonight, if there's still time, maybe we can get some more of that done. Okay, so the last thing is populate the student's gender from the command line. So, you know, well, let me show you something first. Okay, so I've been doing test-driven development, and every time I sort of get a test passing, I commit the code and I push it to GitHub. And you know, this is the benefit for all of you. If you're playing along with home, if you want to see my commits, you can do so. I'll refresh the page here, and look, there's my latest commit. Populate the student's gender on the command line. And you know, before I pushed, I was sure to run my tests, right? Because my tests provide sort of a validation of all the code to make sure that the changes that I made haven't broken anything that used to work. So I was very disciplined and I did that. And it's pretty easy for me to do that because there aren't that many tests. Actually, there's two. There's student test and then there's student IT. However, as your project is bigger and bigger, you're going to have more tests. You're going to have more things that need to be built. And one of the things that I've configured the GitHub repository to do something called continuous integration. So the whole idea is that every time you make a commit to Git and push it up to GitHub, it rebuilds the project to make sure that your code still builds, make sure that everything still compiles, runs all the tests to make sure that things can be run. And so here in Git, you see this little yellow dot here, which means that a build is in progress. And so if you click on it, it says, hey, there's some checks on this code, on this commit that haven't been, that are still being run. So in this case, I build the code with both JDK 17 and JDK 16. And so you can get details here about what's run. So this is actually I guess this is complete now. But what I have, I'll show you here in this project. I have, where was it exactly? It's here in the .github workflows, or these things called GitHub workflows, which represents, well, you know, continuous integration build. So kind of ignore the details here, but basically what I'm doing is I'm saying run run verify. Oh, the order is a little weird. Run Maven verify on a fresh checkout. So make a fresh checkout of my source code. Set up the Java environment because this is a Java build, and run it with Java 16 and 17. And what do I want you to run? Well, run the Maven W script with the verify goal using the pom.xml that's there, and make sure that passes. And so it does that. So GitHub does this for me, right? It sets up the job, it runs the checkout, it sets up JDK 17, and it builds the Maven project. And so if you expand this, here is the output. It downloads all of these dependencies from Maven Central. And if I scroll down here to the bottom, oh gosh, there's all sorts of stuff. But eventually it gets down to the bottom. It runs the Maven build, right? And so you see the build success, just like you do in yours. And what this does is it validates that every time I make a check, every time I make a commit and push up to GitHub, everything still builds. And if it doesn't build, there's a failure. So if I've introduced a compilation error, if I've introduced a failing test, or whatever, it sends me an email saying, whoa, wait a second. Hey, you checked in some bad code. You want to go fix that. And this is great because it provides you automatic feedback. It does a build in a clean room environment, so you're not worried about some partial build that's there on your machine, or it downloads all the artifacts from scratch, just in case you get something corrupted there. And so then this is a really important part of software engineering, because you've basically got these these elves that work in the background to make sure that your code still works and still runs as you evolve it, as you make changes. So that's a super, and it all comes served for free and out of the box with GitHub. That is super nice and super easy. It's one of the things that I like about it. I like about GitHub. And you've got all of that too. Some of you might have noticed this already. If you're getting emails from GitHub saying, hey, you're checking some code that didn't compile, this is why. It's very much on purpose, right? Because otherwise you can go, minutes, hours, days without knowing that you broke something. And that's bad, right? You want rapid feedback. And the fact that it's automatic and the fact that you don't have to do anything is super awesome. Okay. Whew. So we did a lot of test-driven development tonight. Sorry, did you say how many tests we needed for submissions? I'll get to it, Alana. Really, I will. And because the answer is yes, there is an expectation, and I'll be sharing. Actually, I'll be sharing that with you right after break. So let's let's make sure. Let's actually, what we're going to talk about next are the requirements for your projects, everything from testing to documentation to submitting them, and then we'll talk about project 2. And if there's any time remaining, we will do a little bit more coding. But first, take a break. Let's take 10 minutes. Let's take 12. Come back at 8:25.
It fails with the error. So it fails with an error, then it will be exit 1. So then the test fails. So I'm not sure if it is linked or if I did something wrong in the project class.
Oh, awesome. I am so glad you asked that, Lakshmi. So yes, system.exit. So we talk about what main methods do. And so main methods, call the program logic, but when they want to interact with the user, right? What are the methods by which they, what are the means by which they interact with the user? Well, they take input from the command line arguments, and then they supply output via system error and system out. Now, you have discovered the system.exit method, which will exit the VM and provide an error code. And for many, many years, I encourage students to use system.exit to say, hey, listen, the program is done. We're exiting the VM. However, there's always this caveat where, hey, if you have a unit test that calls system.exit, well, that will make the unit test VM exit. Oops, that's bad, right? Because you're right. Let's say you've got 10 unit tests. If your second unit test calls system.exit, well, that's it, game over, and the VM will exit, and the rest of the tests won't run, and the JUnit framework will be like, what? I thought it was run 10. How come only 2 ran, right? So that's why you can't call system.exit. So anyway, so that's what happens when you call system.exit in unit tests. A little side note: for a long time, I had part of that integration test framework when you called invoke main from the integration tests. So invoke up here at the top probably. Oh, I'm sorry. Yeah, the integration tests. There we go. So when we call it invoke main, I used to have a method called get exit code, and I had this magic inside the framework that I was so proud of, because you could trap the call system.exit and you can get yourself the exit code. You could have returned it, and that worked fine until Java 18, where they got rid of the underlying mechanism that I was using, because it probably isn't very secure. So the bottom line is that you can no longer call system.exit in your code. I think I make a note of that in project 1, but just to reiterate, do not call system.exit in your code anymore, because it will only cause pain and heartache.
So if that is the case, so how will exit the class in the first line? So if there are no command line arguments, we are passing an error, and then how we'll exit it?
Return from the main method. Just use a return instead of system.exit.
Oh, okay. Okay.
Right. Yep, that'll work. Yeah. Right. Nice, great question. I'm glad you asked about that. Okay. So we've seen a lot of test-driven development tonight. You've been watching me write a bunch of unit tests, wrote some integration tests too. Sorry, I had some profound statement that I was going to make about unit testing. I thought of over break. Oh, yeah, it's not profound. Okay. You probably noticed it's like, wait a second, we spent like 2 hours doing test-driven development, and really this is all we got. We're barely creating a student. We're just doing this validation. Oh my gosh, this is so slow. Yeah, I mean, for like this silly student application, yeah, it's really slow. We're using this as training wheels though, right? And when I do this for real, I go a little bit faster, but my mouth is going and everything like that. But still, it might seem slow because you're right. We're writing, twice, if not 3 times as much code because we're writing all these tests and everything like that. However, we've got all this protection here. And, these tests that we're writing now, those are going to serve us throughout the rest of the term. So let's say that, for your phone bill, right, so the unit tests that you write with project 1 are going to continue through project 2. But, the logic that we're dealing with here is relatively straightforward. When you get to, the command line parsing, it's pretty easy. But when you get to more complex things like in your project 2 when you're writing your text file, certainly in your project 4 when you're dealing with the REST API, there's some complexity here. And you want to make sure that the functionality works as expected. Yesterday I was writing some code, and basically I was implementing some caching where we call a REST service, and I know this particular REST API is going to go away at the end of July, and what I want to do is I want to change the logic so that instead of fetching stuff from the REST API and then performing some work on it and deriving another result, I wanted to add a cache in there, meaning that when I call the REST API, I want to save the value. And if at any time, if the call to the REST API fails, like let's say the service goes away, then I just want to use the cached result and return that to the client because it's good. I'd rather have something that's out of date than something that is simply broken. And I thought about how to do this, and I'm like, okay, the logic here, I got to do this in that order. I'm like, you know what? No, I want to write some tests. And so I wrote 3 tests that sort of exercise the scenarios that I wanted. And, I had to change a couple of APIs. I wrote these 3 tests. And then once I did that, I understood enough about the problem so that my solution was really easy. I said, oh, yeah, I did a couple things. And I ran my tests, and it behaved as I expected. It's like, wow, I got it right. And for me, it was a good lesson in test-driven development in that writing the test helped me understand the problem that I was going to solve. And not only helped me understand it, but it codified my expectations of how the solution would work so that when I did run the solution, I didn't get it right on the first try. I got it mostly right, and there were a couple of bugs right there that I found within seconds of writing the code because I had this unit test. So, maybe this is a bit of like, hear me now and believe me later, but trust me, test-driven development will make your code better. It won't necessarily make you go faster, but what it'll let you do is find the bugs that you write. Now, maybe you don't write bugs, but I admit that I write bugs. Happens like all the time. And certainly I know people around me write bugs. So that's why I like TDD. I like TDD so much that you have to do it, and TDD you don't have to do, but testing is certainly part of what we do here in advanced programming with Java. So let's talk about the requirements for testing your code. So some more spiel about why testing and automated testing is so important. Back when I was in your chairs in the late 90s, the conventional wisdom was, oh my gosh, if the people who write code also write the tests, why, the inmates will be running the asylum, it'll be chaos, dogs and cats living together, all that kind of stuff. And so then in software engineering, we had these 2 very separate roles. We had the person that wrote the code, and we had the person that tested the code. And like when I started my career, like, okay, I was a developer, and there were testers over there, and so I would do all of my work to the best of my abilities, like, okay, I think this is running, and I guess it's okay. Here, throw it over the wall and test it. And then sometime, usually weeks later, I would get something back and say, oh, no, it doesn't work. I'm like, what doesn't work again? Oh, that code you wrote. I'm like, that code that I wrote six weeks ago? I don't remember that code. It was awful. It was because the feedback cycle was so long. And so I had to remember a bunch of stuff, and I'd be arguing about, well, what's really the expectations is, ugh. So, And also, you know, I thought I was done with it, only to find out that no, there was a lot more other things I had to do because I hadn't thought about test cases. Yeah. So yeah, so the question is, oh, TDD, is this kind of a new thing? Well, no, not really. In that, you know, TDD was first, we began to become popular really on the turn of the century, right? It's been around for 20 years. So if you look at like the Extreme Programming book that probably came out in like 1999, 1998. It talks about test-driven development. JUnit, you know, was again, I think 1999 or something like that. And boy, if you talk to, you know, the small talkers, you know, we've been doing this since the 80s, you know, that kind of stuff. So, no, it's not new, but it hasn't permeated yet because probably what you just saw. It's like, oh my God, it seems so slow. Well, what's slower, you know, being methodical about writing unit tests or having an unknown amount of debugging later on? So, I mean, for me, the return on investment is that, boy, I don't debug code anymore, or when I do, it's only for the really gnarly, hairy problems. The, you know, the sort of like the easy stuff of just implementing logic. You write a test for it, you make it work, you know, you got it done. So, we sort of reached a tipping point in the 90s where, or actually, well, the tipping point probably came a little bit later, where we misspelled the word recently. Where testing is considered, you know, part of software development. It's something that you know, that you do along with writing your code. And in test-driven development, the mantra is write your tests first and then your code second, and then you know that you'll have code that's working and you haven't written more code than is necessary. So to help you, to force you to experience writing tests, I require a couple of things. So when you submit your projects, not only do you submit the stuff in your main directory, you also submit your tests. And then I run your tests when I build your Maven project. And I require a certain amount of code coverage of your test, meaning that 75% of, or at least 75% of your code must be exercised by an automated test, either a unit test or an integration test. So when you run your code with the -t greater option, it activates code coverage. Actually, well, it runs your test with code coverage, and the build will fail if you haven't tested at least 75% of the JVM instructions that were executed. And so then if I run maven w-p greater clean verify, I'll just do that here for the student project. So that goes and it runs. It uses this tool called Jacoco, which is for Java code coverage, to measure the code coverage. And while that's going on, let's read more of this. So we'll take a look at the reports that it generates. But here again, I just want to reiterate, I expect that every class that you write is executed by at least, you know, by an automated test. So you can't have a test out there that doesn't have that isn't executed, or that isn't involved in some test. And that that 75% of your code, technically it's JVM instructions, is executed by your automated unit tests and your automated integration tests. Oh yeah, one more reminder about system.exit. If you call system.exit, then the JVM will terminate and things will fail. And if you don't, if your unit tests, or sorry, if your tests don't provide sufficient coverage, then I'll deduct up to 1 point from your project grade. So this is part of your grade, right? Making sure that not only does your code behave as expected with my test cases, but that you've written test cases that cover 75% of your code base. Let's take a look. Oh, it was passed because it said all coverage checks have been met. And so then what this does is it generates, oops, where is the site, Jacoco? Yeah. Index.html. So it generates this this report that allows you to see for each one of your classes how much code has been covered. And as we can see, okay, it is saying that, okay, I don't have any code coverage for my toString method, which is true, I don't call it. And interestingly enough, it's telling me that there's some code here that isn't covered. Well, I know that's I know this is being called, but that's okay. This is why it's 75%, right? Jacoco isn't 1,000,000% accurate, and it doesn't need to be. But the whole point is that you need to write some tests. Actually, you need to write a lot of tests. But look, okay, I'm feeling good about the fact that like all this code in green here is being covered by my tests. Oops. Oh, note that we saw this a little bit earlier in class, that sometimes when you run tests through IntelliJ after running the code coverage, you get like this funny error about the test engine with ID JUnit-Jupyter failed to discover test. That's when you just do, and actually I don't know if I can reproduce that right now, but like let's run my test again and see if it blows up. Sometimes I notice this funny interaction between oh yep, here we go. Yep, because I ran the code coverage, IntelliJ is confused, so that's all right. Just run the Maven clean, Maven W clean, and that will blow all the stuff in the target directory away. And then IntelliJ will do the right thing when you run the test again. Yep, all happy there. So, these are your testing requirements. So then, yep, up to 1 point of your project grade will be due to your unit test or your testing coverage. Alana, did you have any more questions about tests?
I just asked if we needed javadocs on them.
That's next. You are just like one step ahead of me. So yeah, we're talking about that next.
And
So
I just wanted
testing?
to ask, sorry, I just wanted to ask one more time, how do we see the HTML file that covers?
Yep. It's listed right here in this paragraph, but it's the target site Jacoco and target site Jacoco IT directories. And so then target site, oh, I deleted it. Sorry. it's target site Jacoco.
Thank you.
Okay. Other questions about tests and testing requirements? Okay. Let's talk about documentation. Okay. So being able to express technical ideas in words, especially written words, is an essential part of software development. It's something that I do every day. It's something that every software engineer does every day, even if they don't like words, if they're not a word person or don't like talking with other people. Sorry, software development is a team sport. You have to work with other people. It has benefits for the people around the software developer and the developer themselves, right? Because it helps them, reason about their documentation. It helps them, organize their thoughts, and so then they end up with code that's easier to maintain, easier to read, easier to reuse. So there's a couple mechanisms that we use to document our code. The first one is called a plan of attack. So what a plan of attack is it's a couple of paragraphs about your project, how you're going to approach your project. That I request that you email to me 72 hours, 3 days, so Sunday night before the project is due. And this is just a detailed note to me, talking about what your project is going to do, how it's going to do it, capturing any questions, any ideas or experiments that you want to run with it. That you want to apply to your project. So what I ask you to do is send me an email at whitlock@pdx.edu with letters POA in the title or in the subject, and the name of your project. And please email this to me again Sunday night before Sunday night at 5:30. Now, I have email filters that put all these POAs into their own mail folder. So if you've got something important to tell me in email, please do not put POA in the subject. Oh, and by the way, even if you're using late days for your project, the POAs, I don't accept late, so please make sure to get them in. Now, the whole idea here is that I want you to think about your projects before they're due. I don't want anybody starting them on Tuesday night, and this is just a way to build that discipline in you. So, plan of attack, an email to me Sunday night. Now, javadoc comments. So so as I pointed out, and there are great examples right here in the student class, the Java programming language and the Java standard has these little javadoc comments, which begin with /** and end with // and they describe the program elements, that they precede. So here is a description of what the student is. And here's a little bit more interesting javadoc comment for the student constructor. So there it starts out with a description of what it does, and then for every parameter to the constructor, it has a description of that parameter. And what you can do with this is that you can use a tool called javadoc to create. Let's see here, because I haven't done this yet. To create various documentation based on the source code. So this right here will create some HTML documentation that, and I can open that in Target site API docs. And now I've got this HTML documentation for each of my classes. So if I look at my student class, here I've got all sorts of information, like, okay, it's got these nested exceptions inside it. We can go look at the constructor by clicking on it here. And here we have information about the constructor, and here we have the description of the parameters that come right out of the source code. And so this is the way that API documentation in Java is created. Actually, I've got it configured so it'll go off and link to the API documentation for the Java standard Java API. So here's Java util array list that's linked to from the Java docs right here. Similarly, I can also have links off to my Java docs for the class code. So anyway, it's a neat tool. It's so neat that I want you to do it. So another requirement that you've got in the class is that I want you to write some javadoc code. So the guidelines are a javadoc comment for every class and method that you write. I've told the graders that they can deduct up to 1 point from an assignment from a project that isn't well documented. Now, you don't have to have, let's see here. It's important thing like that. You only need to write API documentation for the main application. You don't need to write API documentation for your unit test, your integration test. That's also interesting. It's just the main application. So your phone bill, your phone call, those classes need documentation, but you don't need but you don't need to put it on the tests. Please make liberal use of the at param, at return, at throws, those kind of tags. And if you want to learn more about it, here's a link off to that. Specifically, what I'm going to do is I'm going to use the -p grader profile with javadoc, and what that gives you is this uses something called a doclet that I wrote that will extract it to text right here, and I'll include this in the output of the tests that I put your code through. And so I'll be able to see really easily that, okay, yeah, main has a good one, but validate gender. There's no javadoc comments here. And so, a student might lose a little bit of credit for this. Yeah, question? Yes, there are partial points, both for the especially the graders, where it's like, yep, hey, especially for the code coverage. So listen, if you are at 70% code coverage, you're not going to lose an entire point. You're going to lose like 0.2 or something like that, right? Right there's something. Same thing for javadoc. So hey, maybe you're really diligent on some classes but not others, or hey, maybe you forgot to put param tags. Okay, you'll still get some credit for it. It's but that's it's up to the grader. Yep. And okay, and so then that's the javadoc comments. Any questions on the requirements for javadoc? Yeah. I won't even look at the javadocs on the tests. I only look on the main code. Yeah, code format. Yep. Oh, HTML formatting in Java, if you want. I'm not. I mean, like I look at it as text, so it'll be like, oh, neat, they used a bold tag. I don't really care. I mean, right? I mean, that's not a requirement. But the requirement is the words, not the format. Yep. Oh, good question. Any other questions about javadocs and documentation and the javadoc requirements? Nope. Okie dokie. Finally, the README. So, in addition to the POA and the javadocs, there is a -README flag on your project, and the whole idea is that this is another concise. This is like sort of the final concise description of what your project does. So, all the command line projects have a -README flag, and by the way, -README is in all caps. That should print a brief, concise, and nicely formatted text description of what your project does. Please make sure that includes your name as well as the name of the assignment. And it should be more than command line usage. So this is sort of separate from the command line usage. This is a description of what it does. Note that when -README is on the command line, all your program should do is print the README and then return. That's it. Don't do any command line parsing. So you can have a completely bogus command line. Doesn't matter if README is there. Just print the README and stop. Now, the README functionality, you can have it, and for many years I told you, hey, just put a big old string in your code, but that's ugly. That's awful. So, what I did instead, so what I started doing a couple of years ago, and actually let's just close this tab over here. Let's see here, close all tabs and group. If you look at, let's see here, this is your project 1 class. Oh, it's not here. It's in the test, probably, isn't it? Sorry? Yeah, project 1 test. Okay. Project 1 test demonstrates how you can load your load a readme.txt resource file into your project. So Java has this concept of resources, which are static files, resources that are used in your application. Think about it like there's an icon in your UI, and you want to have that icon file there in your application, or hey, your application plays some music or something, so you got a MIDI file. Here is like, okay, here's a bunch of text that we don't want to put as source code, right? We don't want a big Java string there in our source code. That'd be ugly. Instead, we want it as a file, and we want to read it in as text and then display it to the user. And so that's what this does right here. So it uses this get resource as stream API to then get the readme.txt file. And let's go look at this stuff. So here we have a test, project 1 test. But if you look over in the main resources, and you've got a directory hierarchy that leads you to the readme.txt. Here it is, simple little file. You will augment it to actually be the real readme. You can put text in here, and then programmatically you can get to that text by using this code right here. Well, actually, most of this code here, you don't need the asserts, but like create the input stream, and you'll be learning about input streams and buffer readers soon enough because you'll be using it in your project 2. And then you use this code to read in the contents of the README from this input stream and that gives you the string, which then you can display to the user. Question, yeah. Mm-hmm. Yes. Yeah, she looks nice. Yep. Yes. Uh-huh. Mm-hmm. Well, if a test passes, it's fine. So the question was like, hey, I looked at this code here, and you're only reading one line. Well, if I want my README to have multiple lines, you need to read multiple lines. I'm not going to give you all the answers, but this should give you enough to start. So yeah, and so then I think, yeah, what Alex was saying was like, okay, yeah, I just had my test verify that the first line of the README contained my name. That's fine. Yep. And here again, just as long as you get the code coverage, I don't really care what your unit tests do, but they have to, I assume that by, having the code coverage, then, but yeah, you'll get the, you'll end up exercising most of the functionality. So anyway, so that's the README as a resource. I encourage you to use that instead of having a big old text blob in your source code. Okay, so those are the documentation requirements for your projects. There are 3 of them. There's a plan of attack, there's javadoc, and then there's the README. Any questions on that? Okay. Okay, so we've been learning all about your projects tonight. We learned about test-driven development. We learned about how to test your projects, how to document your projects, saw the README. Let's talk about how to submit your projects. That's an important part, right? So you've done all this great work. You've gotten all your tests to pass. They provide sufficient coverage. You're happy with what you're doing. Now it's time to submit. So the submit procedures are documented. Oh, sorry. Question from chat. README and print can be in any order input arguments. Yes. Options may appear in any order. Okay. Okay. How do I submit my projects? Okay. Don't need to say the word submit so much. So I think, as I mentioned last week, there are lots of things about this course that I've automated, and it makes it easier. It makes it way easier for me and the graders. It actually makes it a little easier for you too, because some of these things used to be kind of manual and error prone. And I've written some scripts, and I've implemented some I've implemented some things so that it's easier. And one of the things that I implemented was a script called submit.sh. And this is the script that submits your code, your projects, off to the graders to be graded. So this script is run on the PSU Linux machines because it's sorry, let me get stuff up here. So we can all see. So I'm going to SSH. I'll just SSH to myself, I guess. Here we go. Actually, do I have a checkout of 2022 yet? I do. Okay. So here is my GitHub repository. I'll pull the latest changes. Oh, wait a second. I will add myself to this. So now I only need to type my passphrase once. Okay, so now I can pull. All my changes are here. Lots of good stuff. So now I've got all my changes, and now I'm let's say, hey, I've done my project 1. I am ready to submit my phone bill. Actually, let me do Maven W clean verify first, just to see how this is. Just make sure everything works. It's in there running. And what I'll do afterwards is I will run the, let me just make this a little less wide so I can see what's going on over there. Why do I have this big gutter? That's lame. Yeah, sorry. There it is, submit. Okay, it was successful. And so okay, I'm ready to submit my project. I've verified that it works well on the PSU machines, and so I'll run the submit script. So I'll say submit. Submit. Oh, I have to do it from the parent directory. Sorry. Submit.sh, and then I give the name of the project, project 1. And this does a number of things. Actually, I'll just show you, I guess. So it goes off and makes sure that I'm running the right version of Java. It will then build my project. It will do the Maven clean. It'll do it with Grader. This is just another check to make sure that I've got that yes, my code is ready. Oh, it looks like there was a failure that went by there. It probably said, oh, coverage checks haven't met. That's true. My phone bill does not have 75% test coverage. As a matter of fact, it's only got 67%. And so like I would know, oh, look, if I submitted this code, I'm not going to get full credit for the code coverage. So I should go and fix that. I will not, though, because I want to show you what it does. So then after running the Maven build, it goes to submit your code. Now, many years ago, I wrote a little Java program that will take the source code, put it into a zip file, and email a zip file off to the grader, so the grader can then extract it and run it. And so that's what it's doing now. It is putting together a submission for you for project 1. It's telling me, here's all the files I'm going to submit. There's a whole bunch of stuff in project 1. Telling me, yep, I'm going to send an email receipt to my email. By the way, it gets all this information from that me.xml file. And so if you don't have a me.xml file, it will complain about it. Also, if you're not running on one of the PSU Linux machines, they'll complain about it. It will also ask you to approximate how many hours you spent on this project. This is a feature that I added over the winter based on a question from a student. The student asked me, how long does it take to do the projects? I'm like, I don't know. I've never done the projects. How could I find out? I know, I could ask the students, so I did. I added this ability to the submit program for you to specify, hey, here's how many hours that you spent on it. This is completely optional, by the way, and it has no bearing whatsoever on your grade. It is recorded as part of the submission, so I do know how many hours. I don't really care how many hours that you spend on it, but I have all this information, and so I'll show you how I use it here in a second. So let's say, hey, I may have spent 12 hours on this project, and here again, it's an estimate. And say, great, do I want to submit? Yes, I do. And so then it goes, it creates a little zip file, it emails it to the grader, and it tags your GitHub repository. So what it does is it basically says, hey, this is the revision that was submitted. And so now if I look at, well, actually, if I do then do a git push, how do you push tags? Because like if I do a git tag, it tells me that it was submitted there. Oh, how do I? Because right, if I go and I look on my repository, if I refresh, I don't think I have my tags. Oh, is that what it is? Because I don't have any tags here yet. Git push, and then this mother. Nah. Okay, I need to go look at that. Darn. That was the thing I added. Yeah.
I think it's just git push -- tags.
Oh, nice. Okay. Sorry, that's what you meant. Okay. Okay, well, so please do that, because then if you do, then it will show up here. Oh, under tags, that's very nice. And so that the reason I do this is so that you know exactly which revision of your code was submitted. So if you need to go back to like, you know, hey, maybe you get some feedback saying, oh yeah, look, you know, your command line parsing is wrong. Can you go fix it? Maybe you've already started the next project, already made some changes. You can very easily go back to the revision that you submitted. I will add a note to the submit script to remind you to do a git push dash dash tags. Or maybe I can just do that for you. Nah, I'll ask you to do it yourself. Okay. So we have now, this is a submittal process. Yeah, question? Yes. So if you find a bug after you submit, you may resubmit again, and you can resubmit as many times as you want. Just don't do it too many times because it'll annoy the graders eventually. But yeah, nope, that is perfectly fine. Yep. And each time you'll get another tag in your repository. Oh, and by the way, the script does require that all of your there are no local changes, so you have to commit everything to GitHub before you submit. Yep. Oh, thanks for that other way of saying git push remote and then tag. Okay, right, it was the remote that I was missing. But yeah, I git push dash dash tags. That'll work. How do I submit my projects? Okay, so that's the process. You run the submit script. You watch the build go by. Make sure your build is what you expect. It'll verify it'll tell you here's all the code about to submit. You have the option of saying how many hours it took you to that you worked on the project, and then it submits it. It tags the repository and submits it. And let's see here. Oh, some other notes here. You can submit .java.xml and .txt files. You cannot submit your pom.xml because I don't want you to modify it. Instead, what happens is I just get the source code. I will create a brand new project and drop your source code on top of it and run it. So that's how the pom.xml is created. Oh, you can add a comment if you've got there's something that you want to tell me. Just use that as the second argument to the script. Is just say, hey, here's something that maybe isn't working or something that you want me to know. And here is the data that I gathered last winter about the projects. So this is how. So it's hey, for the 5 assignments. Oh wait, question. So so only the pom.xml for git ignore, or are there others? Well, actually, the pom.xml is not get ignored. It's just that it's not submitted. Right, so the submit just looks at everything in your source directory, your src directory. It doesn't look at pom.xml, it doesn't look at target, doesn't look at anything else that's there. Did I answer your question, Jacob? No, that's all right. No, I went over that pretty fast. Yeah. So the data that we have from last term is that of the 21 students who submitted project 1, which is the app classes, on average, it took 17 hours, but then I also do like a whisker diagram. So the median was 14 hours, meaning that half the students took less than 14 hours, half of the students took more than 14 hours. At maximum, one student took 48 hours on project 1. At minimum, one student took 7 hours on project 1. But 75% of the students took 21 or fewer hours. So I use this as you will. I don't know if it helps you plan your, plan your life or plan what your investment is. But this is approximately how long it took. Please don't beat yourself up if you are, if you took more than the median. Don't think that you're the best programmer in the world if you took less than median. Your mileage may vary. No, I don't have correlation between the amount of time they spend and their grade. Yeah, that information isn't terribly interesting to me. If I suppose I could have some sort of distribution of the grades. I would be very curious about how that would be actionable to someone. there's data for me. I want to make sure that data is actionable. I think this is actionable in that you can sort of see, we can plan. Okay, hey, I should expect that it should take, at least 14 hours. That's the median. Again, half the people took 14 hours, and really just sort of looking at the median. Projects 1, 2, and 3 are about the same, and then not surprisingly, the rest and Android take more, but it's only 20 hours, which over the course of a couple of weeks, you can think of that as you will. Okay. And so that's how you submit. So that'll be an important thing. Remember that project 1 is due before class next time. Any questions on that? Nope. Okay, well, let's finish off tonight with a discussion of project 2. So I'll make it big again so we can see it better. Okay, project 2 is due in 2 weeks, which is July 13th, right before class. In project 2, we extend our project 1 by adding the ability to persist, to write and read a phone bill from a text file. So, some of you commented, project 1's kind of dumb. It's, none of this stuff is saved. Well, now it is. So this gives you an opportunity to learn about Java's facilities for doing I/O, for throwing exceptions when things go wrong, that kind of stuff. So you're going to be creating a text file of a format of your own design. You can use whatever you want, as long as you can read as long as the program can read what it wrote. So to provide this functionality, there are 3 new classes that I want you to add to your package. Actually, I think some of them already exist. You just need to augment them. There's a text dumper class that is an implementation of phone bill dumper that takes a phone bill and writes it to a file. Similarly, there's a text parser that takes a text file that was data in the text format that was written by the text dumper, parses it, and from it creates a phone bill with all of its associated phone calls. So that is the new functionality in the project, the ability to take a phone bill and its phone calls, write it out to a text format, and read it in from that text format. Also be a new class called Project 2, which is an augmentation of your Project 1 main method that has all the same functionality as Project 1, but it adds a new option, which is dash text file, which is specifies the location from where the text content should be written and read. Couple of notes. If your program finds the text file does not exist, this is not an error. This is just the way you start a new file, right? So what the program should do is create a new phone bill object from the information on the command line and write the contents of that phone bill to a text file. This is not an error. Note that the text files on the command line, it can be any valid file path. So it could be an absolute file path from the file system, or it could be relative to the working directory. Don't do much validation on the text file, and also don't assume that it must end in .txt or something like that. Don't do any checking like that. The text file can have any name; it can be in any location. Also, date and times, still the same format as the previous assignment, the 24-hour time there. As always, the program should exit gracefully when something bad happens. So no stack traces, no pointer exceptions, things like that. And of course, now because there's more functionality, there are more things that go wrong. So if like the text file is malformed, or if the name in the customer name in the text file doesn't match the one on the command line, that's also an example of an error. Oh, finally, I want to make a note about resources and files. So I showed you earlier tonight how you can use a resource to read a text file into your program. And over the years, I've had a number of students think, oh, this is great. I can use this to read and write files for the text parser and text dumper. No, please don't do that. It doesn't work like that. Resources are different than files. Yes, I know that on disk it is a file, but it's a different concept. A resource is read only. You can't write back to a resource. Even though, yes, you might know it's a file on the disk. Nope, you read and write from whatever is given to the command line argument. Don't use the get resources API for your text file for the program. Use it for your README. Yes. Question on that? Yeah. Mm-hmm. Oh, so the question is, you know, do we support both a dash text file and a dash print? Yes, yes, we do. Options may appear in any order, and all options may appear. Of course, you have dash readme. All you do is do the dash readme and exit, but yeah. Correct. The functionality of dash print has not changed. All you do is print the description of the new phone call. Yep. In project 3, you'll see that there's a way to display the phone bill in a human readable format. Patience Danielson. So nice. Okay. Good questions all around. So once more time to reiterate, only use the resource API for your README. Do not use it to read and write files from the file system. More explanation there. However, you can use, sorry, okay, and here's one thing I also confused. You can use resources for your tests. So like you might have a test for your text parser that reads a resource that has some text that you want to parse, invalid text. And I think that's what I added in the unit test. So I have the text dumper test and the text parser test. So these are meant for you to get started and to give you an example to show you how the text parsing might work. And so here I have I have a test that basically says, hey, I'm going to create a phone bill. I'm going to create a text dumper. I'm going to dump the phone bill to that text dumper, and I'm going to use something called a string writer, which writes to a string in memory as opposed to a file on a disk. And I'm going to assert that yes, the text that was written by that text dumper contains the name of the customer. All right, so this is a very simple test just to make sure that yes, the name of the customer is persisted in the text file format. Oh, question. So dash print or dash readme can occur in the middle of the phone bill arguments as well. No, that is not the case. I guess I say it in project 1. In project 1, I say that options always precede program arguments. So options, then arguments. Cool. So I have this unit test here. I also, the options can appear in any order. All options must appear before the first argument. Yep, all good. Here's another example unit test that takes advantage of the @tempter annotation from JUnit 5 that actually writes a text file to the disk and then reads it back in with a text parser and makes sure that the customers are the text that you read. Sorry, the phone bill that you read has the customer that you expect. Just something to get you started, I encourage you to augment these tests and add more information to the text that's dumped and verify that the text parser can read it. Text parser uses resources, loads some resource files. So here we have a valid phone bill. So right now, my valid phone bill just consists of the customer name. But then what the test does is it reads that resource file into an input stream and then creates a text parser from that, which will parse the input stream from that resource and then validate that yes, the customer that is read from that text source indeed contains the customer name that we expect. Similarly, we assert that if you attempt to parse an empty phone bill, an empty phone bill, a parser exception is thrown by the parse method. And here's another example of that assert throws that we were seeing earlier in class, where this is how you validate that something wrong has gone, or that an exception is thrown by your code. So these unit tests are meant to get you started. They are not the end-all be-all. And just like your unit test for that came out of the box in Project 1, you need to get them working. And so you might have to change them to get them to work with your particular implementation of text parser, text dumper. But I've got you started here to sort of give you some ideas of where you can start. In years past, I had people start from scratch, and it was, how should we say, problematic. Okay, that is project 2. Project 2, again, is due in 2 weeks. It is worth 9 points. One of those points is the POA, and the rest will be determined by test cases. Any questions on that? Nope. Okay, that's all the content that I have for tonight, and boy, we took the entire time. Granted, we got started a couple minutes late, but we covered a lot of ground tonight, and so thanks for sticking with it. So, I hope you got a better idea of what test-driven development is all about the power of refactoring, how we wrote all those tests, and then we went through and did some major surgery on our implementation to go from, instead of returning the magical strings, to have an exception that that describes what went wrong. We also looked at continuous integration to give you rapid feedback on the changes that you commit to GitHub. And then we took a tour through some more requirements for our projects. We learned about how to test our projects, how to document our projects, and how to submit our projects. And we also saw how to work with resources in Java for things like your README, and then also for your tests of your text parser, which you will use in Project 2. Great. Okay. Oh, we did have a student raise their hand. Thank you for doing that. Ryan, what would you like to know?
I spaced on the quiz that was due today. Would it be possible to turn that in late?
Send me an email so I can give you a little extension. Yeah.
Okay, great. Thank you.
It's the first one. No. Just let me know, and I'll extend it for who. If you didn't get to it, I'll extend it until, I don't know, like maybe tomorrow at 5 p.m. or something. I don't know if I'll get to that tonight. So yeah, send me an email, or actually send me an IM on Slack. That'll be better. No problem. Let's see here. Questions, maybe unrelated, but when do the mob programming sessions? Is that in person? Can we do that remotely? So yeah, okay, preview of next week. Yeah, next week we will do we'll do our first pair programming exercise, and that can be done either in person or remotely. It's an attend anywhere, and so then I encourage people to experience both. You'll have an opportunity to do pairing next week and the week after that. If you're comfortable coming, if you're comfortable and capable of coming onto campus, this might be a good time to do it, because you get to use the magical classroom and stuff like that, and work with your peers. But remote is also an option for that. So then if you can't make it into campus or don't feel comfortable doing so, you may participate remotely. Another question? Nope. Okay. Follow up later. Excellent.
I have a question about pair program. How does that work exactly? I'm not very familiar with that concept.
We will cover it in detail next week. But if you want to know, you can check out some of the resources from next week beforehand.
Okay.
It works really well. It's awesome. Maybe that's the way I should have answered that. Cool. Excellent. Okay. Well, hey, thanks for listening, everybody. I hope you learned a lot, and have a great week. I will see you next time. Bye now.